just you can directly name it as, for example, this one is ethanoic anhydride because it is made from just one type of acid, ethanoic acid. You can see I have written the structure, or you can uh, heat two different acid, mixture of two different acid. Suppose if you have mixed together ethanoic acid and propanoic acid, so ethanoic propanoic anhydride. Okay. Similarly, you can have carboxylic acid. Other derivatives include esters. So esters can be prepared by heating carboxylic acid, right, and alcohol. Is it clear? Carboxylic acid and alcohol can be heated together in the presence of concentrated H2S. If you take dilute H2SO4, dilute means you are putting water, so ester will break into carboxylic acid and alcohol, corresponding alcohol. So esterification and ester hydrolysis. Esterification is carried out by heating with concentrated H2SO4 where you remove water. Hydrolysis is carried out by taking dilute H2SO4 where you break the ester into carboxylic acid and alcohol. Got it? So in acidic medium, both can happen depending upon whether you use dilute or whether you use concentrated. Similarly, you can prepare amides also. Amides can be prepared from acid by, first you need to react with ammonia. If you just react, if you don't heat, you get ammonium salt because this is just an acid base reaction. Okay. The ammonia H plus is going to come in and this is acid base reaction. And if you heat it, as you can see, then only you get an amide by the removal of water. Clear? So NH3, if you heat it, if without heating, just make ammonium salt. With heating, just CuNH2. So I hope this is clear to you. Next reaction, this is very, very important, very common reaction. That is from your NCRT only, that is HVZ. This is Helmholtz-Zielinski reaction, and it is basically halogenation at alpha carbon. Alpha carbon, you are putting a halogen. Okay, X2. You are putting a halogen in the presence of phosphorus in X2. The X is going to come in. Yes. This X can be Cl or Br. This X can be converted to other functional group because Br or Cl can be removed very easily. They are replaceable. So red phosphorus in Br2, you are going to get a Br, or red phosphorus and Cl2, you are going to get a Cl, or directly they may give you this PBr3 and Br2. Got it? Clear? So this is how we are going to get the reaction. So that is halogenation. Halogenation, suppose if you want to connect anything to the alpha carbon, just get the halogen and you can substitute that halogen with a nucleophile. So you get any other compound, any other functional group with this HVZ reaction. Next is decarboxylation. This is a step down reaction. Step down means your number of carbon atoms are decreasing. And normal carboxylic acids can be decarboxylated by heating with soda lime. Soda is NaOH and this is lime, is Ca. So it could be given to you, provided to you in terms of what soda lime heat or NaOH CO heat. So the CO2 is going to come out and you are going to end up with an alkane. Got it? This is step down reaction. If you want to get back to carboxylic acid, you can easily react with Br2 H. You will get RBr. Once you get RBr, you can convert it into CN, or by Grignard you can get back to RCS. That was step up reaction. Okay. So normally decarboxylation takes place by using soda lime and heat. Got it? Clear? But there are some carboxylic acid which can undergo decarboxylation without soda lime. Okay, and these are beta keto acids. So beta keto acids, this is the alpha carbon, this is the beta carbon. If you heat them strongly, okay, there is actually a C double bond O on the carbon atom next to next carbon atom with respect to COH. That is beta keto acid. So if you heat it, look how this COH remains. It remains like this. You can see the structure. If you heat it, there is a cyclic transformation of electrons take place and the CO2 comes out. You can see the CO2 break apart and you end up with carboxylic acid without CO2. So that is decarboxylation of beta keto acid. This is very, very important. So wherever you have carboxylic acid, CO2 being removed just by heating, it means it must be a beta keto acid. So I hope this is clear to you. Got it? So now this is carboxylic acid. Let's move on to some questions. Okay, we will do some questions and then we will move to next chapter. Compare the ease of decarboxylation reaction, means how easily the CO2 can come out with soda lime heat. So how easily, these are the three carboxylic acids. That is acetic acid, chloroacetic acid, dichloroacetic acid, and D is the trichloroacetic acid. And you heat them with NaOH and CO, which is going to decarboxylate most easily. If you have electron withdrawing groups, rate of decarboxylation increases. So if you have more and more electron withdrawing group, the decarboxylation is going to be more easier. Okay. So which statement is correct? Which of the following statement out of the first, second, third, and fourth are correct?
Third one.
Third one, yeah. Actually, third one looks very correct, but actually half of it is correct. So you will get a lot of statement where the half of the statement is correct, but the one only that is incorrect by just one word, and that has happened here. So this part is correct, but this is not acylation. Okay, this is alkylation. So overall, this has become incorrect. Got it? Because it is alkylation. Are you getting my point? Because what you are attaching, are you attaching COCS3? Okay, are you attaching COCS3? Or are you attaching CS3 plus to the benzene? Both are field craft, that is true. But if you are attaching just CS3, that is field craft alkylation. If you are attaching CH3CO plus, that is acylation. Are you getting my point?
Yes, sir.
So this is alkylation or acylation? You have CH3 connected, so it is alkylation, not acylation. So this statement became incorrect because I wrote acylation. Got it? This A is what? What is the structure of A? This is basically you are oxidizing, and because you are oxidizing, this CH3 will get converted to COH. So A is PH, COOH. It is benzoic acid. Got it? Because you are oxidizing, so as I told you, the side chain will get completely oxidized to acid. Okay. And what is the structure of B? You are treating this benzoic acid with soda, lime, and heat. Got it? So soda, lime, and heat means decarboxylation reaction. From the benzoic acid, you are removing CO2. So this is benzene. Got it? And the option C is field graft alkylation. I hope this is clear to everyone.
Yes, sir.
Okay, great. So you need to identify the correct statement. Which is correct? Identify the correct statement. So what is the structure of A? Just now we have seen, if you heat the carboxylic acid, simply carboxylic acid, what is going to happen? The water is going to get eliminated. Got it? And if you heat it with P2O5, that is also same thing. P2O5 is dehydrating agent. It is going to remove water. Got it? So what are you going to get? Anhydride. Okay. Meera and Upasana, is it clear or not?
Yes, sir, clear.
Okay. So this is incorrect. And if you heat it with an alcohol, you will end up with an ester. Now second and third both are esters. So which is going to be the right option? Just look at them. This is PHCOOCH3. Let me write it. And that is CH3COOPH. pH is the phenyl benzene ring. So which ester you are going to end up with? You have taken methanol and benzoic acid. Got the point? So they both may look similar, but don't get confused by their similar structure, right? This is acid. This is an alcohol. Okay, just remove the water. You are going to end up with PHCOOCH3. PHCOOCH3. Got it? So I hope this is clear to you. But not this one. What about C and D? What happened to ester if you react with LAH, lithium aluminum hydride? We discussed long back we were discussing in alcohols, we were discussing in aldehyde ketone also. This is a very strong reducing agent, right? And this will reduce the ester to alcohol. Both the part, this one and this one, both will get reduced and separate out as alcohol. So I hope that is clear to you. Got it?
Yes.
Okay, so this again it became incorrect because this is an acid. So if I'm using an LAH, okay, how can I get an acid? Because it will get reduced to alcohol. So it should be that it would is the correct statement should be like this. Okay, but this is not correct. Okay, so alcohol from this and this is already alcohol. So this statement become incorrect. Okay, so answer is going to be option third. Right? So this is about the carboxylic acid and its derivatives. Lot of simple questions are being asked in this manner, and in every examination you will see a lot of questions. So I hope you will be able to do it. Okay. So let's move on to amines. So first of all, amines are actually, they are the alkyl derivatives of ammonia, as you can see. And depending upon the number of alkyl groups, you can have primary, secondary, tertiary amine, or you can also have quaternary ammonium salt. Quaternary ammonium salt means there are 4 alkyl group and there is a plus charge. So this is going to be the quaternary ammonium salt, R. Got it? Clear? So this will have plus charge because the lone pair is also involved in participating in the bonding. Similarly, you can classify the amines as aliphatic and aromatic also. So what's the difference? Aliphatic, so above three which I have shown you are aliphatic amines. You have alkyl group attached, methyl, ethyl, propyl, any of the alkyl group, and these are aromatic amines. Got it? Because you have nitrogen directly connected to benzene. Clear or not? You should also know the common name because these common names are given in your NCERT. Okay. Or IUPAC name. This is aniline is the common name, and benzenamine is the IUPAC name, the common name. And this is orthotoluene, which is the common name, and 2-aminotoluene is the IUPAC name. This is tertiary as well as aromatic amine. Okay, this is N dimethyl aniline or N dimethyl benzenamine. So this is the basic classification of amines, aliphatic and aromatic. Okay. Now the preparation. Preparation is the planning for preparation. Just you need to know that you need to put uh, actually NH2 group on the alkyl group. I hope you are getting my point. You are putting NH2 group on an alkyl group. Got it? So NH2 group, but NH2 group, how to put that NH2 group? You need to have some leaving group attached which can come out easily. And leaving group, the better leaving group is the none other than the halogen itself. Okay. The halogens are fluorine, chlorine, bromine. Most precisely, chlorine and bromine and iodine are very good leaving groups which can break apart easily. And you have NH2 in place of those leaving groups. Okay, and that's how you will get amount. So this reaction is known as ammonolysis of alkyl halide, where you heat the alkyl halide with ammonia in a closed container. The lone pair of ammonia is going to come and attack on the alkyl group, and halogen is going to come out. Then you treat it with a base. Generally K2CO3 is taken. It may or may not be given, but you can directly write your answer as RNH. Okay, so this is ammonolysis where you replace halogen by NH2. Now the next thing is, suppose if you are having fluorine, chlorine, bromine, iodine, what will be the speed? What will be the rate? The rate is going to be maximum for alkyl iodide because iodides can break more easily. Okay, they are the best leaving groups among all the halogens. Next thing is the drawback. So can you tell me what is the drawback of ammonolysis? What's the disadvantage? Any idea? You can see the line below, and with that you can get the idea.
It is a mixture.
Yeah, mixture of secondary and tertiary amines will also be obtained. Pure primary amine is not obtained because the amine which you are getting can react again and again. So you will get secondary amine. The secondary amine can react again with the RX. You can end up with a tertiary amine. Tertiary amine can react again with the RX. You can get a quaternary ammonium salt. Yes, that's the drawback. Got it?
Yes.
Order of reactivity already I explained. The I can break apart most easily because it is a very big, very large bond, very weak bond. So alkyl aldehyde are going to be very reactive and fluorides are going to be least reactive. Okay. So, but roughly you can say that you will get a primary amine, but if I talk more precisely, the primary amine is not the sole product. You will get a secondary, tertiary amine and quaternary ammonium salt also along with it. Got it? So sometimes, as I told you, the base is mentioned and sometimes it is not mentioned. Just you can write it directly also. Okay? Clear? So let's move on to the next part. This is a very important method. And what's the advantage? Can you tell me? Over the monolysis, both are studied simultaneously. So can you explain me what's the advantage over a monolysis? And this is Gabriel thalamide synthesis. So why one should use Gabriel thalamide synthesis instead of a monolysis? What could be the advantage? The advantage is you will get pure primary amine. Pure 1 degree amine is obtained. So no impurities of other amines are found, the secondary and tertiary. And this is how it is carried out. You start with the thalamide, you heat it with a base. This is acidic hydrogen and that is base, so you have a potassium thalamide. In that you react with RX and you get this, then you hydrolyze it to get your amine. This you can recycle back. H plus and then, well, I will write it in steps. You can write it as H plus, so you will get COH. Then in the next step, you can react with ammonia. You will get CO minus NH4 plus CO minus NH4. In the third step, you will get, you heat it strongly, so you get that phthalimide. So from this you can get back to your phthalimide. Also you can recycle it and use it again and again in the process. Got it? So rate is same because iodine bond is weaker than bromine than chlorine, and F is the strongest bond because it is the smallest atom among all the halides. So it is going to be bonded more strongly, and it is a poor leaving group. So it is not going to come out easily, right? So let's do some questions. So what could be the structure of X? So you need to tell me which is the correct structure of X. I hope you are getting my question.
Option
Option, first
3,
option? Yes, option.
third option.
Yes, third option, correct. Because this is what we are getting from potassium phthalimide. This already we are having. This N minus is going to replace something here. So there should be some atom at this CH2 which can come out easily. Okay. Got it? Is
Yes.
that clear? So you need some leaving group. So this is the answer. Got it? But you need to be very careful while judging the structures, okay, because they look same, because you have benzene on both the sides, so it may be a bit confusing if you do it in hurry. Some student may tick mark the second option also because it may look like, but we have already taken this, so the X should not have this part. Okay, let's move to the next question. This is 1,3 bromopropane, okay, and you react it with the potassium thalamide, you end up with A. And A you react with NH3, you end up with B. So what is the structure of B? So which is going to be the right option? This also is a very easy question, but you need to check the details. Got it? Just a second. I think the screen got unshared. So what is going to be the right answer? For the structure of B, this is also quite easy. Just you need to check one very minute thing where you can go wrong. So you attacked on the molecule, reactant molecule, that is 1,3-dibromopropane twice. That was reacted 2 times. First time it was reacted with potassium phthalimide, and the second time it was reacted with ammonia. Got it? So accordingly you can decide. You will have these two groups connected on the both sides of the reactant molecule. So any idea what is going to be the answer? You have these two groups that you know already. So you have on one side you will have NH2, on the other side you have this phthalimide. So this could be the answer. Second one could be the answer. Or third one also could be the answer. So out of second and third, we need to choose. So which is going to be the right option? The second one or the third one?
Third one.
Yes, third one. Why? Yes, the third option is right, because you need to look at the carbon also. There are 3 carbon atoms. And in this case, though the group on the both the ends are correct, but here you have 4 carbon atom. How come that propane became butane? That is that part is incorrect. Got it?
Yes, sir.
So third option is the right option. So I mean to say is, with this question, always have a look on the number of carbon atoms. That is very, very important. Okay. Sometimes everything is okay, just the number of carbon atoms may be changing. So you need to look at the carbon atom very closely. Next is the preparation of amines by reduction. So you have many functional groups where you have multiple bonds, and those multiple bonds can be reduced, and hydrogen can be placed in, can be added on those multiple bonds, and you can end up with NH2 group. So this reaction, this class of reaction is actually by reduction. Okay, there are many other functional groups, but the most important is the nitro compound, reduction of nitro compound. So nitro compound can be reduced to aniline. There are many reducing agents. H2PD is the most common. H2PD on carbon, coated on carbon to increase the surface area. That is very, very important. Next is tin HCl, FeHCl. Metals can give electrons, and HCl can give H plus. So tin, Fe, Zn, HCl, they are also good reducing agent. So these are the two most common reducing. H2PD, if it is written, or H2PDC is written, that is one and the same thing. This is catalytic hydrogenation reaction. And this is metal acid reduction using metal and acid. Tin and HCl is the most common. Other metals include zinc, HCl. That is also very good reducing agent. Okay. So I hope this is clear. Okay. NO2, if it is not there, if you start from nitrobenzene, okay. But if it is not there, you can bring in nitrobenzene by nitration. We had seen earlier. Nitration can be carried out by taking mixture of nitric acid and H2SO4. Then you can reduce by 10 HCl. You can reduce the NO2 group to NH2. I hope this is clear to you. Got it? So by reduction of nitro compounds, you can get. These are some other reductions. And some reducing agent which we were talking about more explicitly, they are written H2PDC, SNHCl, FeHCl, you can see. And they are reducing H2PDC, is reducing NO2 group to NH2. Okay. And with a good yield, you can see here 97% yield is amazing. And SN or FeHCl is reducing this NO2 group to NH2. Tin or Fe themselves got oxidized to tin plus 2 or Fe plus 3. Okay. Not only you can reduce the nitro compound, you can also reduce the amides and nitriles. There are so many other functional groups which contain carbon, nitrogen, multiple bond or carbon, oxygen, multiple bond. They can be reduced. Okay. To give you amides. Okay. The most common of all are the nitriles or the cyanides. Okay. So nitriles already have carbon and nitrogen is there already. Just you have pi bonds, multiple bond, which you can either reduce by lithium aluminum hydride, that already I told you, which is the strongest reducing agent. Okay. And you get CH2 and H2. And we have seen earlier in the aldehyde preparation. In the aldehyde preparation, we have seen that if you use diol H, you are going to end up with RCH aldehyde followed by hydrolysis. But if you are using LiAlH4, which has hydrogens, more hydrogens, so it is going to reduce it to amine. Got it? You can also use catalytic hydrogenation reaction. H2 nickel. Nickel is very good, very reactive reducing agent in the presence of heat and pressure. Or you can use sodium, amalgam, and ethanol. Okay, this is Mendes reduction. So they are very, very important. So nitrile is actually very important as far as conversions are concerned. We have seen nitrile, you can convert it to carboxylic acid. We have seen in the earlier chapter where you can hydrolyze the nitrile with excess of H plus H2O, you are going to get COOH. Nitrile, you can just add one H, but with diol H, you will do the partial reduction and you will end up with acid. Partial reduction can also be carried out with the Stephens reduction. You can use Stephens reduction SnCl to HCl. And if you do the complete reduction using H2Ni, using NaETOH or using LiLH4, you are going to get a primary amine. Okay, so I hope this is clear to everyone. Got it? But very important, as far as conversions are concerned, the CN group can give you amine, primary amine upon reduction. So let's do some questions. This is quite common, you know. This also reduction we have seen just now. This we had seen in the alkyl halide chapter. So you need to tell me the structure of X, Y, Z, So you need to tell me the structure of X, Y, Z, W, and P. P is the reagent. So what is X? Tell me quickly. Yeah, nitrobenzene. This is nitration. And you are reducing the nitrobenzene using 10 HCl. You are getting aniline, PHNH2. Okay. And what about Z? What this X to Y to Z? What reaction is it? From Y to Z. NaNO2 plus HX, HCl. And this is a very important reaction as far as aromatic chemistry is concerned, because you end up with a group which can be replaced by the group of your desire. And this is synthesis using diazonium. So Z is the intermediate aryl diazonium salt. Got it? This diazonium is very reactive. It will react and we can't stop it. So but which group is going to come in place of N2? That is the question. And in this case, we have taken CuCN and HCl. So which group is going to come in its place? Tell me. In place of N2 plus or N2, which group is going to come and occupy in the position of N2?
Cyanide group.
Yes, cyanide group. And this is Getterman reaction or Sandmeyer reaction? And this is benzonitrile. This is the common. IUPAC name is benzene carbonitrile. Got it? This, suppose if you use copper powder, that is Getterman reaction. But if you use copper salt and HX, that is Sandmeyer. If I would have written copper and HCl heat, then it will be Getterman. It is also used to put bromine and chlorine on the benzene. Now once you have CN, you can easily end up with benzylamine, PHNH, PHCH2NH2, just by doing the reduction. reduction is P, so P is going to be, there are many options. It could be LH, which is a very good reducing agent, or it could be, just now we have seen H2 nickel. Got it? So there are multiple options available. Got it?
Yes, sir.
Okay, let's move to the reduction of other functional groups. The other functional groups are actually, you have amides. Amides already have N, but you have CO. So just reduce them by strongest reducing agent LAS, and you're going to get with CO being changed to amide. Okay, primary amine. So whatever the amide you are having, accordingly you will end up with primary amine. Accordingly, primary or secondary. If you start with secondary amide, which is having two alkyl groups, you are going to get secondary amide. If you start with a tertiary amide, you are going to get a tertiary amide. So I hope this is clear. LH can be used. Got it? So till now, just let me recall, we have seen the reduction of NO2 to NH2. We have seen the reduction of CN to CH2NH2. We have seen the reduction of amides CONH2 to CH2NH2. Got it? Look, these are some specific examples.
Yes, sir.
So now these are both are amides, you can see. Okay, very clearly you can see. So, but suppose I have written it here, so that's why you are able, sometimes if it is asked like this, so which is the reagent, they will hide it. Okay, and then you need to tell me which could be the reagent in place of this LH. If they don't ask you, then it becomes difficult. If they don't show you, then it becomes difficult. So they may give you options like what this X could be. X could be NaBH4. Can it be NaBH4? Yes or no? We know because it was written earlier that it should be LH because we are doing the reduction. But what about the other reagents? NaBH4 is also a reduction, but it is a mild reducing agent that we discussed in the chapter of alcohols. So being weak reducing agent, it will not reduce the amide. Got it? And these two will not be an option because they are hydrolysis. If you do the hydrolysis, then you will get carboxylic acid and amide. The ring is going to get cleaved. So again, this is not an option. Got it? So reduction just amide. Do remember, all other carboxylic acid derivatives, they are going to give you alcohol. Only the amide is going to give you an amine. Okay. Now this is preparation of this is again the preparation of amine, but very, very important, right? So this is basically step down preparation, right? This is step down reaction. So step down basically means what? You are actually decreasing the number of carbon atoms. Okay. So suppose if you want to if you want to get an amine with one carbon atom less, then you should think of this method. And what this reaction is, let me share the screen again. By that time you can also try to name it, what the reaction is known as, where you get an amine with one carbon atom less than the parent amide. Okay, in the above reaction, we were getting amine, but we were getting the amine with exactly same number of carbon atoms. Got it? And in this, you are getting an amine with one carbon atom less. Look, this is your amine, and this is the amide. So CO actually disappeared. Okay, this is step down reaction. Are you getting my point? So if the question demands reduction in number of carbon atom, then you should use Hoffman bromamide degradation method or Hoffman hypobromide method. This is known by various names. Getting my point? So
Yes, sir.
you have to react with Br2 and base. So first of all, you should know the reagent. Br2 and base will remove the carbon, and you are going to get an amine with one carbon atom less than the parent amide. This is how the mechanism takes place. But first, I suggest all my students to know what is the reaction, what is the reagent, what is the purpose, how to write the product without getting into the details of the mechanism. If you directly get into the mechanism, yeah, mechanism is actually good. I'm not saying that you don't require it. You require it. Definitely you will require it. But if you get too much obsessed with the mechanism, then sometimes it may be time consuming process. Okay, suppose if I get a very small question, just one conversion, I'm not going to write all these steps. Got it? Got my point? I just need to write the product as quickly as possible by keeping the mechanism in my mind, at the back of the mind. Okay, so mechanisms are important. They help us to know that which is the main product, which is the minor product. But mechanism actually every time, that doesn't mean that we should write them every time. If you write them every time, that is going to be a time consuming process. Okay, so what you do here is how it happens is you take an amide, you react with KOH. Okay, and in the presence of Br2. So this is acidic hydrogen. These hydrogens are acidic. They will be removed by the OH minus. You will end up with N minus. N minus, because that N minus can undergo resonance and form O minus. That N minus can combine itself to the Br. Then once you have a Br attached, the remaining H will be removed once again by the base, Br being removed, and there is a shift happening of the alkyl group. Got the point? I hope everybody is getting my point.
Yes, sir.
So now you have, this is the intermediate. isocyanate. And this undergo hydrolysis with in the basic medium. So this turns to acid, carbamic acid, and this ultimately breaks into an amine. The CO2 comes out, okay, and that was the CO2 which was present as CO. So you can observe that you have an amine with one carbon atom less than the parent amide, because the C double bond O of the amide is now liberated in the form of CO2. Got it? So this is the complete detailed mechanism, and you have a rearrangement of alkyl group which lead to the formation of isocyanate, then the hydrolysis, and then the removal of CO2 to get an amine. So all this is a detailed process, but you need to write the reaction, it is very easy. Okay. So let's do some question, and with that it will be more clear. So what is the structure of C? That you need to tell me. Yes, what is the answer? Tell me quickly. The reaction is very simple. Can you tell me what is the right answer? So first we started with Hoffman degradation that lead to the formation of A, as you can see here. Got it? Then you heated it, and what has happened, that has already been mentioned, minus H2O. Got it? Water being removed. And then from B to C, some reduction was carried out. Got my point? So all the reactions which we discussed today are there in this question, right? So tell me, what is going to be the final answer? Any idea? Meera and Upasna, tell me quickly. So this is Hoffman degradation. Look, very simple. This is Hoffman degradation. This became NH2. Okay. So this Cu got removed and you end up with NH2. So this is option A. Then you heated it and that led to the formation of an amide. And then today only we have seen that the LH will reduce it. So you are going to get an amine, right? So C will be the amine, though actually second and fourth option and third option, all three are amines. So out of which only the third one is a matching option. So I hope this is clear to everyone. Got it? So let me end today's class, and by the next class we will be able to complete amines, and maybe we will start the coordination compounds very quickly. So let me end the class. I hope this question is clear to everyone.